This is paper 3, video 1 for the February mock. The first topic we're going to look at is vectors. For this sort of question, it's just going to be a quick 1 or 2 mark question, so it doesn't need to involve a lot of work. So by that, it suggests it's going to be quite easy to do, hopefully. For the first one, we've just got that the vector m is 3 minus 2, n is minus 5, 4. So when it says these different combinations of questions, these combined vectors, all we do is do these combinations to the vectors above. So for m plus n, that would simply mean I would need to do, for the top number, 3 plus minus 5. 3 plus minus 5 is the same as 3 take away 5, which is minus 2. And for the number at the bottom, I would have to do minus 2 plus 4, because I'm just adding the numbers at the bottom together, which gives 2. So that would give us the vector minus 2, 2. 4m would simply mean 4 lots of the vector m. So 4 times 3 is 12. 4 times minus 2 is minus 8. So that would be the vector for 4m. We've got 2m plus 3n next. Well, 2 times 3 gives us 6. Plus, for the top number, 3 times minus 5. 3 times minus 5 is minus 15. So here we've got 6. Take away 15 effectively. So minus 9 for the top number. For the bottom, we do 2 lots of minus 2, which is minus 4. Plus 3 lots of 4, which is 12. So minus 4 plus 12 is 8. So the combined vector would be minus 9, 8. Same idea with these ones. 4m, so we do 4 lots of 3, so 12. Minus 2 lots of minus. Sorry, my mistake, I've misread the question. So minus 2 lots of 3, which is 6. So the number on the top would just be 6. 4 lots of minus 2 is minus 8. Take away 2 lots of minus 2 is minus 4. Now, minus 8 take away negative 4, that's the same as saying minus 8 plus 4, which is minus 4. We could have actually cheated on this one, this which what threw me earlier on. 4m take away 2m, we could have just done the vector 2m. The next one, m minus 3n. So m is 3, take away 3 lots of n, so 3 lots of minus 5 is minus 15. So the number for the top would be 3, take away minus 15, that's the same as 3 add 15, so 18. And then for the number at the bottom, m, so that's just minus 2, take away 3 lots of 4, so that's 12, minus 2, take away 12, would be minus 14, and there's my combined vector. And for the last one, n, so that's minus 5, take away 4 lots of m, so 4 lots of 3 give us 12. So for the top number, we've got minus 5 take away 12, which is minus 17. And then on the bottom, n, so we're using 4 for that one, take away 4 lots of minus 2. So 4 lots of minus 2, as I said there, is minus 8. 4 take away minus 8 is the same as 4 plus 8, which gives us 12. And there's our combined vector. The next topic we've got is changing the subject of a formula. So here, in each of these 3 questions, we're going to try and make m the new subject of the formula. There's a couple of ways of thinking about this. I always try and look at what I've actually done in the original formula to the new subject, and then try and undo that. So here, if you look to this letter m, we've times by 3, then taken away 4. so I need to do the opposite of both of those, but in reverse order. So first I would add 4 to both sides. So over here it would give me x plus 4 equals 3m. In order to get that m on its own, I would have to do the opposite of times 3, so divide by 3. So if I divide by 3, I get m is equal to, and dividing all of that by 3 will give me x plus 4 over 3. The next question, look, the m is going to be the new subject, so here that 2 means times 2, then divide by t. So I need to do the opposite of these two things here in reverse order. So the first thing we're going to do is get rid of this divide by t. So if I times both sides by t, that will give me, over here, ct is equal to 2m. Then I'd need to divide by 2. So that gets me the m on the right hand side and ct over 2 on the left. The final one, there's a quick cheat way of doing this, which I'll mention in a second, but because m is now at the bottom of this fraction, we can't actually rearrange anything to do with the fraction until we move this m. So the first thing I would do here is multiply both sides of this equation by m. That would give me mhf is equal to w. And then to try and get this m on its own, I would need to move the hf. Now, because they are both multiplied by each other, or both multiplied by the m, we can move them in one go simply by dividing by hf. So it gives me m equals w over hf. So the little trick I mentioned before, if the thing that is the new subject is just there on its own at the bottom of a fraction, all you actually need to do is just swap over those two bits there. So if you look, the m is now up here on its own, the hf that was on its own up here is now at the bottom of the fraction. Next topic we've got is all to do with relative frequency. Now normally when you get a question to do with relative frequency, it will ask you to find the number of times an event occurs based off the relative frequency and how many times you're doing an event. So for instance, if it had been this one, if it had told me that the relative frequency of it landing on 3 is 0.2, I would have had to do 0.2 multiplied by the total number of times that the dice was rolled, and that would give me the number of times that I would expect it to land on the number 3, so in this case 150. Now this question has done this a little bit in reverse, so what it wants us to do is find this number, how many times it was actually rolled. So I've got 0.2 times something equals 150, so I'm just going to solve this. I'm going to do the opposite of 0.2 times by this and divide by 0.2, so 150 divided by 0.2 gives me 750, and that must be the total number of times that the dice was rolled. Similarly, on the next question, we've got a spinner this time, because we always seem to like going for spinners and dice within maths. It lands on purple 60 times. So the relative frequency of landing on purple was 0.15. So if this were a normal question, I would have done 0.15 multiplied by the total number of times that the spinner was actually spun. And that would equal the number of times it landed on purple, which we're actually told in this question. So we get that. So to find what number we're missing here, to find the number of times the spinner has been spun, I would have to do 60 divided by 0.15, which in this case comes out as 400, and that will be the total number of times that the spinner is spun. The last topic for this video is all to do with inequalities. Now we've seen some inequality questions already on the other papers. This one, very similar. We are going to try and solve the inequalities that we are given here. And we are also being asked to list all the integer solutions. Now remember, integers means whole number only. Now to solve this first equation, what I'd have to do to try and get that letter x on its own is I would have to divide it by 4. So if I do 4x divided by 4, it gives me x. The inequality symbols do not change, but I'd have to then divide both of these numbers by 4 as well. 12 divided by 4 gives me 3. 24 divided by 4 is 6. So this would be the solution that we were asked to find. We are then asked to find the integer solution, so to list the whole numbers that would work for this. Now x can't be 3 because it says that it's bigger than 3, but x could be 4, 5 or 6 because of this extra line here. X is less than or equal to 6, so it could be 6. The next question, very similar idea. To find x on its own, I would have to divide all of it by 2. 9 divided by 2 is 4.5. 3 divided by 2 is 1.5. And then I'm just going to put the same inequality symbols in as the bit above. Now this bit here tells me that x is less than or equal to 4.5. But if I only want whole number answers, the first whole number it could be is 4. It could also be 3, 2. I can't write 1 because as it says here, it needs to be bigger than 1.5. Next question, 5x. So I'd have to divide both sides by 5 here. So 5x divided by 5 is x. 20 divided by 5 gives us 4. 10 divided by 5 is 2. And I'll pop the little inequality symbols back in. Now this means that it's less than 4 but bigger than 2, and it cannot be 2 or 4, so the only integer solution we've got here is 3. Then for this last question, we've got the x, so I've divided by 2. 16 divided by 2 is 8. 22 divided by 2 is 11. Pop the inequality symbols back in. So x could be 8 and is bigger than 8 as well. So it could be 8, 9, 10. Just need to check with this one. It says x is less than or equal to 11. So I could also have 11 as a possible integer solution.